Hello, Honored Algebra students. Here's Mr. Lawrence with the homework help, I promise. All right, look, these story problems are really pretty easy, but we need to make sure we're reading carefully and not just grabbing numbers. We have to read them in context. Okay, so let's start off. This is going to be problem number 3. I think I'm going to do 3 and 9 and show you possible ways to do them and then see if you can mimic what I'm doing on the other problems. Okay, so the length of a rectangular playground is 10 yards less than 3 times the width. Well, the first thing I need is a rectangular playground. So let me get a rectangular playground here. Okay, now it says specifically that the length is 10 yards less than 3 times the width. So I need to know the width first. Now I don't know the width, but I'll call it W. I'm not going to call the length L. I don't want to introduce multiple variables. If I have two variables and one equation, you won't be able to solve it. I don't know how to solve one equation with two different variables. I can graph all possible solutions, but there are actually an infinite number of them. So I need to keep the same variable. So I'm going to do to the width what this underlined part right here says. First, I need 3 times the width, or better yet, 3W. Now I need 10 yards less than 3W, so I will take away 10 from that answer. Okay, so that is the original playground. Now, what's going to happen is they are going to add a baseball diamond next to the playground. The width is going to be decreased by 15 yards. Now, I saw some people in class today trying to like uh, redraw, like draw on the same thing, and I think it gets too confusing. So I'm actually going to draw another rectangle. Okay, and it's not going to be as long or as wide because in the story I know they're being decreased. Now, the new width, let's see here, the width of the playground is decreased by 15 yards. So my new width becomes W minus 15. And the length is being decreased by 35 yards. Well, if this is my first length, and if I take 35 away from that, won't I have 3W minus 45? Now the new area is 675 yards squared. Well, how do I get area? By multiplying the length times the width, or the base times the height. So I'm going to do W minus 15 as a quantity times the quantity of 3W minus 45. Okay, and that'll have to equal 675. Now, this isn't one where I can just solve W minus 15 and 3W minus 45 for my answers. Um, Actually, a thought just occurred to me. Hold on a second. Okay, sorry about that. I just had a thought in my head, and I tested it, and I was correct that you can't do that. So what I'm going to do here, if it equals 0 right now, I could set them equal to 0 and solve. But they don't equal 0, so I'm going to FOIL. So I'm going to get 3W squared. On here, I'm going to have a negative 45, and here I'm going to have a negative 45. So I'm going to have a minus 90W, and then a 45 times a 15. Well, let's see here. If I do this, and I can go multiply, we're going to get 5, 2. We got 25, and 2 is 7. Carry the 2, 675. Ooh, I like that. Plus a 675. That's going to equal 675. Now I'm going to set it equal to 0 by subtracting 675 from both sides. And when I do that, I end up with a 3W squared minus a 90W. Those cancel. Those cancel. I get equals 0. What am I going to do here? Well, this is where I'm going to factor. I'm going to solve the quadratic by factoring. Looks like a GCF problem to me. I'm going to pull out a 3W and be left with W minus 30. Okay, let's do solutions. 3W equals 0 and W minus 30 equals 0. One will get me the answer of W equals 30 yards. The other one will get me the answer W equals 0 yards. I will give anybody $10 if they can draw me a rectangle that has 0 for one of its dimensions. Can't do it. So there is the width of the rectangle, the original one. Now, if I want to figure out the length, I'm just going to plug that answer for W right there. So I'm going to get 3 times 30 minus 10, which I believe will be 80 yards. So the length is going to be 80 yards. Okay, so the length is 80 yards. Now, if you really want to check your answer, just do the same thing that they said to do and multiply. So they reduce the width by 15, so the new width is going to be 15, and the new length is going to be reduced by 35. So 80 minus 35, well, 80 minus 40 would be 40, so the new length is going to be 45. And sure enough, I know from my work earlier, if I multiply those two together, I get the 675 that I'm after. So there it is. That's problem number 3. It's actually pretty simple. Draw the pictures, label them appropriately. Don't just grab numbers. Don't you go, oh, I see a 35, and write 35 down. Ask yourself what's going on with the 35. Okay, and then set up your equations and FOIL and then solve by factoring. After you set it equal to 0, of course. Okay, problem number 9. When the square of 2 consecutive integers, first of all, what does consecutive mean? It means in order. Okay, even means we're going to be skipping the odds. For example, 2, 4, 6, 8, and so on, right? Okay, what is the first of 2 consecutive even integers? Well, I'm going to let x equal the first even integer. That Z symbol means integers. Okay, well then the next one, you might want to call it y, but again, I told you, don't introduce a new variable. Just think, name an even integer, like 14. What's the next one? Well, of course, it's 16, right? How did you get there? You added 2. Okay, how about 36? The next one would be 38. How do you get there? Well, I add 2. How about 1,614? Well, the next one would be 1,616. How do you get there? You add 2. So if my first integer is x plus 2 must equal the second consecutive even integer. Okay, so when the square of 2 consecutive there's a typo in here. Okay, and I fixed that typo, sorry about that. And I think it is it's just mine. I think on your worksheet it says, okay, when the square of the second. So it's no problem, your worksheet has the right problem, but I typed it wrong making the video. So I apologize for that. Okay, sorry. So I need the square of the second. So I need to take the second of the consecutive even integers, which would be x plus 2. But I need to square it. That is a FOIL problem. That is not x squared plus 4. Make sure you're doing that right. Is added to twice the first. Well, that would be 2x. The result is, or the sum is 76. So first thing I'm going to do here is I'm going to FOIL. And I'm going to get x squared plus 4x plus 2. And I have plus a 2x, and I have a 76. I'm going to combine my like terms. And I'm going to also subtract 76 at the same time. So I will be left with x squared plus 6x minus, oops, I have a silly mistake, don't I? I'm just full of silly mistakes today. Okay, this will be plus 4. There we go. Good thing I caught that, otherwise Austin would try to say he's one up on me. All right, so I'm going to have a negative 72, and that's going to equal 0. Now I'm going to factor. Now, learning the factoring tricks I talked about the other day, I know that I can do this, and I know factors of 72 are 12 and 6. I could go plus 12 and minus 6, and that ought to work. Okay, now there's going to be two possible answers. One, x might equal negative 12, in which case x plus 2 would equal negative 10. The other possible set of answers are x would equal 6, in which case x plus 2 would equal 8. Oh, excuse me. There are my two possible sets of answers. Okay, so if I want to check them, you know, let me square the second one and add it to twice the first. Well, if I square the second one here, I'm going to get 100. And if I add twice the first, I'll be adding a negative 24, which would equal 76. Hey, that's good. If I square this one, I get 64. And if I add twice the first, I get 76. So you see both sets of numbers work. Okay, there you go. There's two problems done for you. Good things to model. All right, these will be on the test. They won't be on the quiz that you're having Thursday. All right, Mr. Lawrence signing off. Have a good night, everybody.